Hi and welcome to this video on hyperbolas. They're slightly different to the standard ones that you might learn in math methods, but they have the same ideas of asymptotes and approaching things. Essentially, we've got sort of two focal points, here. So we'll call this, point A and point B, and we've got some other point out there somewhere. And what we're going to say is that this distance here minus this distance here is always equal to some constant k. Let's just say that it equals 5 or something. And then what we can do is we can actually get this distance here, subtract that distance there, and that will be 5, and keep doing this indefinitely like this. And what we end up getting is some sort of shape like that. And if we did it from the other side, we'd get some sort of shape like that as well. And so we'd have asymptotes along here and asymptotes along here, and that's what the parabola would end up looking like. We could have that, or alternatively we also could have something that does this as well, so that asymptotes stay in the same spots, but we have that one instead. Anyway, that's just the big idea of what's going on. Let me show you actually how to do these. I'll just get rid of this. Okay. Right, so the first question I've got is x squared on 9 minus y squared on 4 equals 1. So this is the standard kind of form that we're going to be looking at, so something minus something else. Notice that it's slightly different to ellipses, because ellipses have a plus in the middle. I guess circles also have a plus in the middle as well, so if you look at C. But these ones have a subtraction. So we probably need to work out a couple of things. I'm probably just going to focus on working out the x-intercepts first. X and y-intercepts, but although in this case, for the first one, it won't have y-intercepts, and I'll show you why. So let's work out the x-intercepts. So y equals 0. So we've got x squared on 9 minus 0 equals 1. So that means that x equals plus and minus, don't know what's happening here, x equals plus and minus 3. If you rearrange this, you should get that. All right, we're back in action. So x squared equals 9, so x equals plus and minus 3. Okay, so let's in fact draw that somewhere. Sorry about that. So we've got that down here. So x equals positive 3 and also negative 3 as well. Okay, now we're going to work out the asymptotes from this as well. Now this is going to be a little bit tricky, but hopefully you can bear with me. Oh, before I do that, there can't be any y-intercepts, because if you have a look at this, if x equals 0, you get negative y squared on 4 equals 1, and y squared equals negative 4. And unfortunately we can't do anything that, because you can't get the square root of a negative. Although I know you can with complex numbers, that's not relevant in this particular topic here. Okay, so because we're only dealing with real numbers. Right. So now we're going to look at how to get the asymptotes here, and this one requires a little bit of tricky algebra. So let's just give it a go. I'm going to get y squared equals something y squared equals something else, just because that's how we usually sketch graphs. So x squared on 9 minus y squared on 4 equals 1. And so I'll drag the y squared on 4 onto that side and the 1 onto this side, so I get y squared on 4 equals x squared on 9 minus 1, just by rearranging it. You can have a look at yourself if you want to. And now I'm going to multiply both sides by 4, so I get y squared equals, I'm going to leave the 4 out the front, I get x squared on 9 minus 1. Now what I'm going to do is, I can't really get the square root of this. Well, I can, but it's just not really going to be helpful for me. What I'm going to do is I'm going to take out a common factor of x squared on 9. I know that seems a bit strange, but hopefully you'll be able to see where I'm going with this. So y squared equals 4x squared on 9, and then I'm going to have 1 here. And what have I done to take x squared over 9 out as a common factor? I've actually divided by x squared over 9. So I'm going to do that just over to the side here. It's negative 1, or 1 divided by x squared over 9, which is the same as 1 multiplied by 9 over x squared. Okay, so I get 1 minus 9 over x squared here. And now I can get the square root of all of this. So it's y equals plus minus 2x over 3, and then the square root of this, 1 minus 9 over x squared. Okay, now here is where I'm going to get my asymptotes from. Again, I have to do a little bit of fancy maths here. What I'm going to do is I'm actually going to substitute values of x in just to see what values of y that I would get. I could start with, say, subbing in x is 10, seeing what would happen here, or x is 20, or x is 50, or 100, and I could get larger and larger all the time. Imagine that I made the x such a large number, like a billion, for instance. What would end up happening is this number in here, 1 minus 9 on x squared. If x squared is actually a billion, I'm going to get 9 divided by a billion, which is actually really, really tiny. So I'm going to get 1 minus something really, really tiny. And then I'm going to get the square root of 1 minus something really, really tiny. So let's just say it's like 0.98 or something in here. The square root of 0.98 is actually going to be less than 1. Okay, so therefore I've got here, what was it? If x is a billion, so I've got a billion multiply something that's less than 1, which means x is a billion. How do I write a billion? That's a lot of zeros. There we go. And y is going to be just slightly less than this. So what we're going to happen is we're going to have this line of y equals x, and each time as x gets larger and larger, y is going to be slightly less than that. So that's actually where the asymptote comes in. Oh, sorry, when I say y equals x, I shouldn't have that. I should have y equals 2x on 3. And it's going to be slightly less than that number each time. Hopefully that makes a little bit of sense to you. So we're going to get this asymptote that comes and does something like that. And this is going to be the line y equals 2x on 3. Now I could also do the same thing with negative a billion. If x is negative a billion. In fact, I probably should be using infinity, but I just thought sometimes infinity is a bit hard to think about. So, but positive infinity, negative infinity, and I'm going to get this line that goes through the origin and does that. And so this one is going to be y equals negative 2x on 3. Now, what happens is as the x value gets larger and larger, I end up getting closer and closer to this line, but never actually meeting it. So I end up having something that looks like that, and I end up having something that looks like that. So this is the shape of the hyperbola. You've got those asymptotes there, and you've got these lines here, which look very much like asymptotes. Hopefully they've drawn correctly. So that is actually the shape of the hyperbola. Okay, so probably the two things to note is how to get the x-intercepts, and there's no y-intercepts, and also how to get these asymptotes here. Essentially, it's just going to be this part here as x approaches infinity and negative infinity. So I hope that's helped. I might do a couple more videos just to give you a few more examples. Thanks.